Thanks to all of you who voted on my YouTube poll and also who gave me feedback on Blue Sky and Astrodon on which version of Jupiter to choose. Democracy prevailed, and this is the final official image. It's officially been 10 years since I first took a picture of Jupiter through a telescope. And the picture you saw today was my best one to date. So I think it's safe to say that I got a little bit better. Stay tuned and I'll tell you about the capture and processing techniques I used, as well as maybe a weird technique that I used to focus my telescope. And then we'll take a closer look at Jupiter, and then finally we'll look at the time lapse that I created, where we can see Jupiter rotating along with 3 of its moons orbiting the planet. Jupiter is at opposition now, and although it's not as close as it was to Earth last year, it's still magnificent. Going back in time, this was the best image I was able to take of Jupiter in April 2013. It was a single image and it's barely processed. Move forward 1 year to April 2014, I was able to take multiple images and stack them, and this is the shot that I got. It looks much better. Unfortunately, I didn't try again until December 2020 when Jupiter and Saturn were in conjunction, and unfortunately this is the only shot I was able to get due to weather-related obstacles. Then in 2022, during opposition, I was able to capture this image of Jupiter. Not only that, I was able to take my first time lapse of Jupiter rotating over 2.5 hours. If you look at all the images side by side, I clearly improved my capture and processing techniques. So let's go over the gear that I used. This year I used the exact same telescope that I used in 2013, my Nexstar 6SE with a native focal length of 1500mm at f10. Back then I used my AVX mount, which I still have in use, but for this session I used my CEM40 mount. And I used an Astrocam, my ASI533MC Pro, instead of my Canon T2i DSLR, which I used in 2013. I also used an Orion Shorty 2x Barlow, which makes my effective focal length 3000mm at f20. Now the weird way that I focused my telescope, it's not really exactly weird. I used a Bahtinov mask, or a Bahtinov mask, I think that's how you pronounce his name. We use Bahtinov masks to focus on stars and deep sky objects. It's normally not used for planetary, it's really hard to, but I thought I would do it anyway, bump up my gain, my gamma, and my exposure settings to see what I can get, and this is what I was able to get. You can clearly see the diffraction spikes on Jupiter itself, but what I actually used was the diffraction spikes on the little moons to the side here, if we zoom in a little bit, and those look like little stars, and I used that to focus, and I think it worked really well for me. And as I just mentioned, I took videos using fire capture. As for my settings, I used the default 341 gain, which is the unity gain for this camera for this kind of setting. And I recorded at about 15 milliseconds, or 14.91 to be exact. I didn't use any gamma, and I took 1,000 frames for each of my videos. And I took enough videos to turn them into a time lapse of Jupiter rotating over 80 minutes. It's not as long as last year's, but it's still pretty good, and it looks pretty sharp. You'll see that time lapse in this video soon, and I'll also upload that separately as a shortly. My dream is to image Jupiter for 10 hours and get the entire rotation of the planet. It's really hard to do because you have things like houses, trees, and other obstacles that get in the way, especially clouds. But one day I hope I can go somewhere where I can image Jupiter for 10 hours straight and see it rotating all the way. As for the time lapse, I took 32 videos, and as mentioned, there are 1,000 frames each. There are a couple of jumps because of intermittent clouds, so I had to either stop recording or throw those frames out because there were just nothing I could get. And this is what one of the raw videos looked like. You can see the atmospheric turbulence making the planet look wobbly, but the seeing conditions that night wasn't too bad, actually. After I put the video through AutoStakkert, this is the output that I got. Then I did some sharpening and wavelet manipulation in AstroSurface, and this is the result. I also did white balance editing in AstroSurface, and I had a question for all of you on which looked better in my YouTube poll, as I mentioned earlier, and you chose which one was better, and that's the one I went with. Getting a closer look at Jupiter, we can see its 3 Galilean moons here. We have Europa, Io, and Ganymede here. They look pretty big and bright here. On the very far hand side, we have a very dim Callisto. It's a little bit hard to see, but it is there. It was a little too far for the processing, so let's just pretend like it's not there for this image. I didn't do any further edits in Photoshop or GIMP or anything else. I did batch processing in AutoStakkert and AstroSurface once I was satisfied with one of the frames, and then I turned that into a time lapse in Adobe Premiere Pro. If there's interest in seeing how I process the image in AutoStakkert and AstroSurface, let me know. I can also provide one of my video files as an example for you to use when you're following through. I just have to figure out where to put them because they're all 4 gigs each, even though they're just 1,000 frames. They're raw videos, so I just have to figure that out. I hope to see you soon. Let's get to the time lapse. Clear skies.